Hi, in this short video today, we're going to have a look at how different LLMs can help with tuning database performance. So some of you may know that DBmarlin has had a built-in copilot for just over a year now. And so when you get to identifying a statement like this one here, this is Oracle database, we've got a slow performing query. Here you can see the plan. So rather than having to tune this manually, you can just send this off to the copilot. And without you doing any typing, it sends a prompt that looks something like this. Hard for a human to read, but easy for an AI to make sense of this. So if we give that a few seconds, you can see it's come back with some suggestions here. It's saying that indexing is the number one suggestion. And we're already filtering on passenger count and pickup date time, but we don't have an index on those. So in this case, a composite index on pickup date time and passenger count would make sense. And then it goes on to suggest other things, such as partitioning, updating your statistics, and various other things like join strategies and materialized views. But in this case, the number one suggestion here by far is this composite index. In fact, in this case, I already applied this, and you can see this is what it looks like now. Instead of, if I just go back to the previous one, this is what it looks like when you're doing a full table scan. On the rates table is just a lookup table, so that one is very small, doesn't really matter, it's a full scan, but this one is a very large table, so the cost is very high, 27,000. And then if you compare that to once I've added the index that was suggested by AI here, it's now doing the index range scan, and you can see the cost of that operation is now 9 compared to 27,000 when we were scanning the whole table. So that's obviously the benefit that you can see from indexing databases. And so in this case, the AI, the built-in AI, was able to get that answer. If you look at the small print at the bottom, this built-in AI is using GPT-4o from OpenAI. So that's the built-in one. But if I clear my OpenAI key, you can see now from version 5.5, we have this use your own LLM feature. So what I'm going to do is I'm going to just try exactly the same thing across Microsoft Copilot. I'm going to look at GPT-4o, if you use that natively, Google Gemini, DeepSeek, and also Granite, which is an open source model from IBM. So now I've cleared my OpenAI key. If I do send to Copilot this time, in fact, sorry, let me just go back to the non-optimized version of the query. That one already had the index. This one's doing the full table scan here. So if I send that to the Copilot now, you can see we've just got a copy prompt button, and that just basically copies all that text there that would normally have got sent straight to the DBmarlin Copilot. We can now copy that and we can paste it over here. So I'm going to run that here in Microsoft Copilot. I'm going to run it here in GPT-4o. I'm going to run it here in Google Gemini. I'm going to run it here in DeepSeek. And I'm going to run it here against the Granite open source model. And then we'll go back through them in turn and just see what suggestions it came up with. Remember, the thing that we're looking for here is that the combined index across these two columns. So the columns that are in the where clause, so the pickup date time, which is used there twice, and then the passenger count. That's the thing that we're looking for that gives by far the biggest performance impact on this query. So let's have a look which came up with that. So this is Microsoft Copilot. It's saying optimize indexes, rate code, pickup date time, and rate code columns. These will help speed up the join and where clause. It then goes on to say query rewrite, execution plan analysis, table partitioning, parallel query, materialized views, and updating your statistics. So it's quite lightweight. I guess we could type follow-up messages, but the initial response here is quite lightweight. It mentions the columns, but it doesn't say about creating a combined index. It doesn't give us the create index statements that we need to do. So let's have a look at the next one. The next one's GPT-4o from OpenAI. You can see this one does say indexes on the rides table. Majority of the cost is that 27,000 accessing the rides table by a full scan. Since you're filtering on pickup date time and passenger count, indexing these columns should help. First of all, it's suggesting single indexes on the individual columns, but then it's saying if pickup date time and passenger count are often queried together, like in this case, then a composite index may work better, and it actually gives us the exact create index statement that we can just copy and paste. So that's a better response. It does go on to say things like materialized views, partitioning, updating your table statistics. In this case, it actually gives you, again, something you can just copy. This is how you can update your table statistics for Oracle. It knew that it was Oracle, so dbms stats gather. Table stats is the command here to update the stats. And it also goes on to say you can force the index using a hint to the optimizer as well. So this is a better response than the Microsoft Copilot. Let's have a look at Google Gemini next. So it's straight away saying create composite index on rides. And again, it's got the create index statement. In this case, it's gone for 3 columns, but it's the 2 that we wanted, particularly date time and passenger count. It's also included rate code. Rate code was used in the group by, and it was also used in the join conditions. A 3-column composite index may also give you a good result. Is then talking about analysing your tables, and it's giving the analyse commands. It talks about partitioning and other bottlenecks down the bottom. So this is, again, a very good response. Next, if we move on to DeepSeek and see what DeepSeek came up with. So starting from the top, it spotted that it was a full table access on the 2 tables. It suggested addition of indexes, index on pickup date time. That's just a single column index. But then it also then goes on to say composite index on rate code and pickup date time, which is interesting. And then it's saying a single column index on passenger count. Okay. And then index on rate code. Rate code is a small lookup table, so that one won't have so much impact. But interesting, yeah, it's come up with a combined index, but a different combined index to what the others came up with. This one may give you some benefit, but I would imagine not as much as if you included passenger counts into the composite index up here. So I would say so far, OpenAI and Google Gemini are winning, slightly further behind. And then last of all, let's have a look at this open source model. So this is Granite, the 3.1B. This is actually just running locally on my laptop, so this is a cut down model. So I wouldn't expect this to give as good a response as some of the others, but let's see what it came up with. Indexes, create index on rate code on the rides table, pickup date time, and passenger count. So those are the individual columns. In this case, it hasn't come up with the composite index, which is what I would want, some combination of these 3. Avoid using functions in the where clause, materialized views, a little bit on that, partitioning, updating your statistics. In this case, it has given the correct command, gather table stats, to update the stats on both the tables, and then look at tuning the sort operation. Okay, so I would say, again, this is probably on par with things like DeepSeek and maybe Microsoft Copilot. It's not coming up with a composite index, but it is suggesting that you need to look at indexing these things in the where clause. So overall, I would say OpenAI and Google Gemini are the best for this. The other 3 that we've looked at here are pretty close. Actually, just to throw one more into the mix, another one that I have been looking at recently, which is Perplexity. I can just copy exactly the same prompt again. Let's have a look, see what Perplexity makes of this. I've been getting some pretty good results with this one, so it'd be interesting to see what it comes up with. So this one is saying indexing, and it's straight away gone for the composite index on the rides table, create index on pickup date time, passenger count, and rate code. So again, this would be one of the better options, I would say. It then goes on to partitioning, materialized views, and you can see in each case it's actually giving you the code that you can just copy and paste into your IDE. Yeah, updating your statistics, again, it's got the correct command there for Oracle, and also hints. So I would say, yeah, Perplexity, definitely one of the top ones as well. So here, just to summarize the results of this test, this is what I found. You can see this is purely subjective, just based on my own assessment on one fairly simple example here. I've just given them stars out of 5 for how I thought they rated. So Microsoft Copilot was okay, probably on par with DeepSeek and Granite, so I've given those 3 stars out of 5. The best in this test by far were Google Gemini, OpenAI 4.0 model, and Perplexity. Those 3 all came out with the key thing in this case, which was that compound index across multiple columns there. So I would give those 5 stars out of 5. So LLMs can be a massive time saver when it comes to tuning database statements. This example was a fairly simple one, but this also works across some much more complex statements. AI can be a huge time saver. Things that might take a human, even a database tuning expert, hours to understand and to optimize, AI can usually come out with a response in about 30 seconds. So a huge time saver there, even for database experts. So yeah, LLMs have come on a lot in the last 12 months. When you're tuning database statements, they can be a massive time saver. So yeah, definitely check them out. And if you're not already using DBmarlin, have a look at DBmarlin. There is a free version where you can monitor any one database of your choice, and the Copilot there is free to use as well. Let me know how you get on, and check out for more videos coming soon. Thanks for listening.